friends, I am Chandan. This is my handwritten notes useful for GATE, ESC, SSC JE, ISRO, DRDO, BARC and other competitive exam. The PDF link is given in the description. You can download it. Let's try to understand. This is the second chapter of thermodynamics, that is zeroth law of thermodynamics. Let's try to understand what is zeroth law. Suppose consider this is a body, this is body A, and there is another body, this is body B, and there is another body, this is body C. If body A is in thermal equilibrium with body B, and if body B is in thermal equilibrium with body C, then the body C must be thermal equilibrium with body A. So this is known as zeroth law. Okay, so here suppose consider there is a beaker is there. This is the beaker. In this beaker there is some water is there. So consider this water is body A. This water is body A. Now in this water there is a bulb is there. This is the here. This is the bulb is there. And consider this is body B. And inside this bulb there is a marker is there. Inside this bulb there is a marker is there. So this consider this is body C. So if body A temperature, body A is in thermal equilibrium with body B, that means water is thermal equilibrium with bulb, and if body B is in thermal equilibrium with body C, that is mercury, then body C must be in thermal equilibrium. Body C must be in thermal equilibrium with body A. So this is known as zeroth law of thermodynamics. This is invented by scientist Fowler in 1931. Okay, now let's understand what is zeroth law. So if a body A is in thermal equilibrium with a body B, and the body B separately in thermal equilibrium with body C, then the body C must be in thermal equilibrium with body A. So this is the zeroth law. Here we see that there is a mercury inside this bulb, and we see that when the temperature increases, the volume or the property change of the volume changes due to this temperature difference. So here thermometric property is mercury. So here thermodynamic property is mercury height or volume. The whole concept of thermodynamics, the whole concept of temperature measurement is given by zeroth law. From zeroth law, we can understand the temperature measurement, the concept of temperature measurement. In zeroth law, body C act like a thermometer. Okay, so this is all about the zeroth law. Now let's understand what is temperature. Temperature represent average random energy per unit molecule. Hotness or cold is a feeling associated with heat transfer. Okay, so this is all about the temperature. Now thermometric property means when the temperature changes, the mercury height is or volume changes. So that is why here thermometric property is mercury. Okay, so what is thermometric principle? That is, according to this principle, first we found the property which vary with temperature, and with the help of this property temperature will found, and the property which helps the temperature is known as thermometric property. So here the above case in zeroth law, there the mercury which is responsible for determining or finding the temperature. So here the thermometric property is mercury volume, okay, or mercury. Okay, so this is all about the thermometric principle. Now there is a different types of thermometer is there. In physics you read that resistance thermometer, that is you can say that Wheatstone bridge. So in Wheatstone bridge there is a P resistance is there, and there is a Q resistance, there is a R resistance and S resistance. This is a variable resistance S. Is there, and remember this, you read this formula, that is P by Q, that is equal to R by S. P by Q, that is P resistance by Q, that is equal to R by S. Now just same, there is a resistance P and Q is there, and there is a variable resistance SS, and this R resistance is connected to the body. So actually this is the body resistance. Okay, so the same formula you apply, that P by Q, that is equal to R dash by S dash. From here R dash, that is equal to P by P S dash by Q. Okay, so there is another formula, R dash, that is equal to R0 into 1 plus alpha t plus beta t square. From here temperature will be found. So this is very important. R dash, that is equal to R0 into 1 plus alpha t plus beta t square. So alpha or beta both are constant. So here resistance play the role of thermometer property. So this is the resistance thermometer. This is the resistance thermometer, or you can say that there is a thermistor. Okay, there is a 4 types of resistance thermometer is there, and there is a thermocouple is there, constant volume thermometer, and there is a constant pressure thermometer is there. Okay, so this is the all about the resistance thermometer. Now there is a thermocouple or Seebeck effect. Seebeck effect is that, suppose there is suppose there is ice is there, and there is another side there is steam is there, and here there is two dissimilar metal are connected in this way. Due to this temperature difference, there is an EMF is generated in between these two metal. So when this EMF is directly proportional to temperature difference. So here EMF is directly proportional to temperature difference, and EMF is equal to K into temperature difference. From here you can calculate the constant value. Now if you want to calculate the body temperature, then same way you connect this steam at the right side, and there is a two dissimilar metal connected in this way, and there is a body you can measure the body temperature. So you find out this K. So we know the formula EMF, that is equal to K into delta T. Delta T means 100 minus body temperature. So here K is known and EMF will be known if you apply EMF here. If you applied EMF, so EMF will be known. So from here TB you can find out the TB. So so let's try to understand what is Seebeck effect. So here, according to Seebeck effect, if two dissimilar metals are joined to form two junction, and these two junction are maintained at different temperature, there will be an EMF induced between two junction, and this EMF is directly proportional to temperature difference of two junction. Okay, so this is known as Seebeck effect. Now there is another effect. There is a Peltier effect is there. Peltier effect. This Peltier effect in refrigerator, it is used because by using EMF temperature will be created. So in Seebeck effect, due to this temperature difference, the EMF will be created. But in Peltier effect, when there is a EMF is there, then there is a temperature difference will be created. So this is all about the Peltier effect. Peltier effect is just opposite to Seebeck effect. So here, that is Peltier effect is used in thermoelectrical refrigeration system. Thermometric property is EMF. So here the thermometric property is EMF. So this is all about the thermocouple or Seebeck effect. Now let's another, that is constant volume thermometer. Constant volume thermometer, we know that ideal gas equation PV equal to MRT. So from here you can say that P by V, that is equal to constant. So this is the constant volume thermometer. So you can say that V equal to constant. So from here you can say that P proportional to T. So P equal to K into T. So this, in this relation, from this relation you can find out the temperature. So here pressure play the role of thermometric property, because pressure is changing due to this temperature. So that is why pressure play the role of thermometric properties. Now there is another last thermometer, that is constant pressure thermometer. That is here volume plays the role of thermometric property. Why? So you know that the formula PV equal to PV. So you know the formula P V by T, that is equal to constant. When V equal to constant, you can say that P proportional to T. So from here you can say that P equal to K into T. That means temperature is changing with respect to pressure. So here the volume play the the role of thermometric property. Okay, now note point is that ideal gas thermometer is independent from material of construction. Okay, remember that is ideal gas thermometer is independent from material of construction. So this is something about zeroth law. In next chapter we will cover thermo that is temperature scale and temperature method used before 1954. So in next lecture I will cover this. Okay, okay, like, share, subscribe my YouTube channel. Thank you.